In today's video, we are going to see how the softmax function works. So in multi-class classification problem in neural networks, when in your output layer, you're giving a softmax activation function, what do you expect is a probability of values for those many nodes. So if there are 3 nodes and the actual output is, let's say for example, minus 0.5, 0.2 and 0.4, what you are expecting is the same length vector but in the probability terms. So maybe this is 0.01, 0.02 and so on. The addition of all this should be equal to 1. So this is a k-length vector of values between 0 to 1 so that you can consider them as probabilities. That is what the softmax function is expected to do. What's the mathematical formula for the softmax function is exponential of a particular value. So in this case, exponential of minus 0.5 divided by the summation of all these exponentials. Okay. Exponential turns negative values also into positive values. Okay, so to generalize it, the softmax function is exponential of a particular output divided by the summation of all the outputs of all the classes. Okay, so this is the formula. Now when you do this, you will get the same length vector, but the answer will be in the probability format. Let us see this in our Jupyter notebook. So let's import the libraries and let's have this problem. So I have just shown you the figure here. When you draw a figure and you just do an exponential, it turns negative values also to positive values. So you can have in the exponential minus infinity to plus infinity values which are negative. The answer for them on the y-axis will be, which are like very highly negative, that will be very close to 0, and which are very highly positive, that will be very close to 1. For example, instead of these 3 points, if I just take a series, a range of minus 10 to 10, and let's take the exponential of the same range. Okay, and let's see the graph. You'll see that the negative values, right, from 0 to the negative values, they are very close to 0, and the positive values very quickly they tend to give you a large value on the y-axis. So what is the softmax function? You can define the softmax function like this: an individual input divided by the sum of all those exponentials, right? I just explained you. So let's take the exponential of this particular z, and rounding off to 2 decimals. So this is 0.18, negative has become a 0.18, 0.2 is 0.37, and this is 0.5. When you do a summation of this thing, that time you will get the answer as 1. Okay. So what is the softmax doing? It is kind of taking the exponential, turning your negative values, the output negative values, to positive values and then normalizing it, right? So if you think about it, this is giving the output as positive values and then normalizing it so that we get it in a probability format. Now what happens if we just do the normalization rather than converting it to positive values? If I do the normalization, what is the issue? So when you do the normalization just without the giving the positive values, you get this answer. Okay, for this particular example, minus 5, 2 and 4. Now here you don't get the values as, you cannot interpret them. You can definitely normalize it, but you cannot interpret the values. Okay, and hence we take softmax. Another thing was, if we just take the argmax, okay, in case we just take the argmax, what is the issue? So if we take the argmax of z, what will I get? I will get a single value, which is the maximum value, the position of the highest value, right? So this will give me the position where I have the highest value. Now in this case, this is the maximum value and I'm getting the position here as 2. If I kind of do a one-not encoding of this would become 0, 0 and this would become 1. Now if you do a back propagation of 0, 0, 1, in the learning phase there is nothing which will be learned for these two classes. Okay, so to avoid these issues, we use the softmax, where even in the learning phase, suppose this was in the learning phase and not the final answer, the negative value would still get some probability so that learning can happen also on these these classes. Okay, then let's suppose take the case of just two nodes. The output is 2 nodes. This is a binary classification. The way in neural networks you can make binary classification in the output layer is either you give a softmax with 2 nodes, or you give in the output layer you give a sigmoid with a single node. Okay, the activation function being softmax or sigmoid as a single node. What will happen in the case of sigmoid, when you have a single node, you will have a particular threshold of 0.5. Anything above 0.5, greater than equal to 0.5, you will say this is class 1, or if it's less than 0.5, you will say it is class 0. In case of softmax, what you will get 2 probabilities, and whichever is the highest probability, you would consider that as the final answer. What happens if we apply sigmoid on these two values? If we apply sigmoid on these two values, let us see what happens. Will I get the same answer as the softmax of this, or I get a different answer? Okay, so what is the formula for sigmoid? 1 upon 1 plus e raised to minus z. So if you think about it, sigmoid is just converting a single value to a probability function. Okay, so you just have a single value to a probability function, whereas softmax is considering a multiple values and then it is converting it into probability function. Okay, basically into probabilities. So let's see this in code. So as I mentioned earlier, in sigmoid we'll obtain isolated probability because it is not a probability distribution over all the predicted classes, whereas softmax is a probability distribution over all the predicted classes. So let's say now you have these two inputs. This is a sigmoid function, and we'll do a sigmoid and a softmax of this, the same input. The sigmoid, the summation is not up to 1, whereas the softmax, the summation is up to 1, and that is because of this reason. Sigmoid, we just obtain isolated probabilities, and hence if you are doing a binary classification, if you are using a sigmoid function, it's always good to use a single node in your output. So if you have a single node in the output, use the sigmoid activation function for binary classification. If you are using 2 nodes as the output, then use the softmax as the activation function. I hope this video helps and it clarifies about softmax and sigmoid, when to use and what is the math behind it. Thank you.